Hey everyone, welcome to Unit 4. We're going to start with compound interest loans and investments as our main overall topic for this term. So our goal today is to model a compound interest loan or investment using a recurrence relation. All right, so we were working with recurrence relations last term in terms of arithmetic and geometric sequences, and we're going to move into using that specifically in financial maths for the foreseeable future. So we're going to do this online with this PDF document that is up on eLearn for you. So let's get stuck right into it. If we're going to model a compound interest loan or investment using recurrence, this is our general formula. And this general formula is on your formula sheet that you're going to get for your external exam. All right, it states that AN plus 1 equals RAN, where AN is the initial value, AN plus 1 is the value of the investment after it has compounded, okay? And don't forget that the rate is 1 plus the interest rate per period, okay? And we always write that rate as as a decimal. So we're going to do two examples with this today. In both examples, we have to write it as a recurrence relationship and use that relationship to solve some problems. So let's get to it. In example 1, we have a person invests $5,000 in a financial institution at 6% per annum compounded annually. Using A0 to represent the initial investment, write this investment as a recurrence relation. So a recurrence relationship, as we saw before, looks like this. AN plus 1 equals RAN. And we're going to write pretty much exactly that, but with something a little bit different. We're going to write AN plus 1 equals RAN, okay? But we need to figure out what R is. So let's just go to the side here. This is question A. R is equal to 1 plus 0.06, okay? So I've just immediately done the interest rate per period divided by 100 in my head there. In other words, R is 1.06, okay? Subbing that back in on the left, AN plus 1 equals 1.06 a to the n, where we usually write this as a little comma, just move that over a teeny bit, A0 equals 5,000. Okay, so this is actually how we would answer part A for that question. So we've written the recurrence relationship and we've stated the first term. This is very similar to what we did last term, where we had Tn plus 1 over here and we stated T1 after the comma. Let's have a look at question B. Complete the table to show the growth of the investment after 3 years. Now, in this table situation, this is just a way for us to see what's actually happening when we use this formula. Okay, so you're not always going to be you're not actually going to be expected to use a table at any point, but you may find it easier to work this way. So here's what that looks like. In the first year, originally we put $5,000 in, okay? The calculation based on this formula here is going to be 5,000 is AN. We're just going to multiply that by 1.06. So our calculation is 1.06 times 5,000. And that gives us, at the end of the year, that we have $5,300 in the account. So this is just after the first year. We started with 5,000, we had the compound, we end up with 5,300 at the end of year 1. We're now going to repeat this 2 more times. So now, at the beginning of year 2, we start with 5,300. 1.06 times 5,300 is 5,618. So that's the end of the second year. So the beginning of the third year, that's how much money we've got in our account. Do our compound interest calculation according to our recursion formula up the top. So at the end of the third year, we're going to have $5,955.08. Make sure you do those on your calculators as well, guys, so that you know what to do. And if I were you, I would do exactly remember what we did last term where we wrote 5,000 equals and we wrote times 1.06 and then we just hit equals 3 times and we got boom, 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 respectively. So I would definitely encourage you to continue doing that. And based on the exams I marked a couple of weeks ago, a few of you did this iterative method on your calculator really, really well. So congratulations to those of you who did that really well. And obviously saved you a lot of time, and you did very well on those questions. Part C says how much money was in the account at the end of 3 years. Well, I didn't mean to do that. Whoops. Well, the amount of money at the end of the account, in the account at the end of 3 years is this much here. Okay, so $5,955.08. So let's write that down. 5955.08. Okay, nice and easy. And part D says how much interest was made in 3 years. Well, remember guys, if we want to figure out how much interest we have made, if we started with $5,000, we now have $5,955.08. We're simply going to subtract 5,000 from the amount we have now. Okay, so we're going to go 5955.08 minus 5,000, and that's going to give us a total interest of $955.08. And that's our answer to part D. So make sure you take the time now to pause, write all that down if you haven't already, and we'll move on to our second example on the next page. So this is when we have a change in compound period. As you know, and we've spoken about this in class a few times, we don't often compound annually. In fact, it's much more common to compound monthly in bakes in real life. So let's have a look at example 2. The person in worked example 1 invests $5,000 in a different financial institution now at 6% per annum compounded monthly. So that's the only thing that's different between the two examples. Part A says, using A0 to represent the initial investment, write this investment as a recurrence relation. Well, the thing that's going to be different about this is we know our recurrence relation has to look like this, RAN, but we need to figure out what R is. So R is equal to 1 plus 0.06, and don't forget, we now need to divide that by the number of times it compounds in a year. So that's why I'm dividing that by 12. If I pop that all together, I end up with the answer 1.005. That's a 0. Okay, so I can write my recurrence relation as AN plus 1 equals 1.005 AN. And don't forget the comma where A0 equals 5,000. So that's just our initial value. So it looks really similar to our previous one, but we now have a different compounding R factor at the front because we're compounding monthly now. Now, using your calculator in the iterative method, calculate the amount in the account after 1 year. This is where you're going to get out your calculator. You guys are going to press 5,000. You're going to hit that equal sign. All right. And then you're going to hit times 1.005. And you're going to hit the equal sign from there exactly 12 times. Because that will be how much money is in there after 12 compounds or 12 months. If you do that, you go boom, 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 boom. You're going to end up with the answer of $5,308.39 in the account. All right. So that's our answer to that one there. And just remember, if a question like this comes up on the exam, just make sure you tell me that you're using the iterative method on your calculator, which again, some of you did that in your exam that you've just done last term. Really great communication. Thank you for that. So how much interest was made in 1 year? That one's nice and simple. We're just now going to take this value, minus it from the initial value so we can see how much money we've made in interest. So let's go 5308.39 minus 5,000 is 308.39. Okay, so that's how much interest that we've made in the first year, which is really nice. It's free money. Woo. And the final question says, how much more interest? So this is a comparison question. I'm going to highlight that. How much more interest was made in 1 year when the interest was compounded monthly instead of yearly? So when we have it compounded monthly, we made $308.39 in interest. And if we look back at our previous question, after the first year of compounding yearly, we made $300 interest because 5,300 minus 5,000 is 300. All right, so if I write here, yearly, we made 300. Oops, better pop my dollar signs there. $300 in interest. So we better make sure we write a sentence when we compare our answers, okay? We will say that $8.39 more was made in interest by investing in the account that compounds monthly. And just a really key thing there as well, guys, is that I'm actually stating how much more. I noticed in our exam a few of us forgot when we're doing our comparisons, remember we need to state how much more something is than something else. So with that, your questions in your textbook are questions 1 to 16 of exercise 7.2. And if you have any questions, make sure you email me. Thanks, guys.